Yeah, okay, thank you. Hello, everyone. My name is Haoqiang. It's a pleasure to be here to introduce our work, Fine-Grained Textual Inversion Network for zero-shot composed image retrieval. I will introduce our work on the following points. First is the background. In the test of composed image retrieval, it allows users to search target image with a multimodal query comprising a reference image and a modification test that describing modification demands over the reference image. It enables users to flexibly express their compressed query intention. For example, giving an image as shown below, the modification wants to be black and more professional. Then we retrieve the target image and write from the database. Existing CIR methods heavily relies on supervised learning paradigms. However, the time-consuming motion human annotations inevitably constrains the generalization ability of these methods. Therefore, recent researchers have introduced a new test of zero-shot CIR, which aims to addressing CIR without requiring any annotated training triplet. According to the different learning paradigms, the existing CIR tests can be divided into three categories: supervised learning, few-shot learning, and zero-shot learning. Specifically, existing zero-shot CIR studies are all based on the technology of textual inversion. The pioneer zero-shot CIR studies focus on converting the CIR test into a standard text-to-image retrieval test by pre-training a textual inversion network. During inference, the reference image is converted into a sentence with a pseudo-word as seen, and hence it seamlessly integrates into the token sequence of the given modification test, forming a unified test query to retrieve the target image. However, the cross-grain textual inversion network may be insufficient to capture the field content of the image accurately. Meanwhile, in CIR tests, users' modification requests generally fall into subject-oriented and attribute-oriented. The former involve alerting the categories or numbers of the primary subjects in the image, while the latter pertain to changing the attributes, such as backgrounds and semblance of the primary subject. Therefore, in this work, we plan to map the image into a subject-oriented pseudo-word token and several attribute-oriented pseudo-word tokens to comprehensively express the image in the textual form. However, this is not trivial owing to the following two challenges. First, images of different domains usually involve diverse local attributes. For instance, images from the animal domains usually contain the attributes of background, postures, birth, while the images of the fashion domain typically contain the attribute of sleeve length, waist size, and color. Therefore, how to effectively capture the diverse local attributes across different images poses a crucial challenge. Thus, we propose the dynamic local attribute feature extraction strategies to handle the difference of local attributes across images in different domains. Second, due to the layout corresponding subject labels and attribute labels for each image, how to jointly regulate the projection of both subject-oriented and attribute-oriented pseudo-word tokens to eliminate the difference between clip visual embedding space and clip text embedding space forms another challenge. Therefore, we propose to leverage the tribe-wise caption-based semantic regularization to enable the thorough interactions between pseudo-words and real words. In this work, we propose a novel fine-grained textual inversion network for zero-shot composed image retrieval. It consists of two components: fine-grained text pseudo-word token mapping and tribe-wise caption-based semantic regularization. The former map the image into a subject-oriented pseudo-word token and several attribute-oriented pseudo-word tokens to comprehensively express the image in the texture form, while the latter focus on jointly aligning the fine-grained pseudo-word tokens to the real-world token embedding space based on a brief-generated image caption template. In the first component, based on existing work, we utilize clip as the feature extraction backbone to extract the global feature and local patch feature from each image. Then, for the subject-oriented pseudo-word token mapping, we directly employ a mapping network to project the global features into a subject-oriented pseudo-word token. For the attribute-oriented pseudo-word token mapping, as mentioned above, the type of attributes usually vary across images from different domains. Therefore, we first assume that there are a specific number of latent local attributes present in all open domain real-world datasets. We then learn these local attribute features for each image by adaptively aggregating as local patch features. Then, to mitigate the diverse impact of the learned noise in relevant attributes, such as the color length attributes for an image with natural scenery, we introduce a dynamic local filtering strategies to retain only the relevant local attribute features for each image. Finally, we employ another mapping network to project the local attribute features into the real-world token embedding space. Both mapping networks are composed of 3-layer-based MLP. Besides, to guarantee that different local attributes can indeed represent different visual attributes, we introduce an orthogonal loss that enforces the distinctiveness of each feature. To supervise the pseudo-word token learning with unlabeled pre-training image datasets following previous work, we adopt the symmetric contrastive loss. Intuitively, we expect that for each unlabeled image, its pseudo-word-based textual representation should be more aligned with its original visual representation than the visual representation of other images, and vice versa. The second component targets jointly aligning the subject-oriented and attribute-oriented pseudo-word tokens to the real-world token embedding space. For this end, we first employ script to generate the real-world description for each image, which is typically in the format of primary subjects and detailed description. For example, giving a brief generated real-world description, we can split it into two parts. T subjects refer to a brief person describing the primary subjects of the image, while T attributes refer to scaling down a snow hill with a mountain in the background, conveying the local attributes information about the primary subject. We then design 3 test templates based on the generated captions to facilitate a type-wise, namely subject-wise, attribute-wise, and whole-wise caption-based semantic regularization, and promote not only the interaction between the pseudo-words and their counterpart real words, but also that between the pseudo-words and the other contextual real words in the image caption. We conduct extensive experiments to validate the effectiveness of our proposed method. It can be seen that our method achieved SOTA performance on fashion domain datasets Fashion IQ. It also shows promising results on open domain dataset CRR. In open domain dataset CRR0, which is designed for zero-shot CRR, our work consistently outperforms all zero-shot baselines. To verify the importance of each component in our model, we compared our model with various derivatives. Even derivatives are without filters. We disabled the filter criteria. Results show that our models exceed the derivative in various evaluation metrics, which validate the effectiveness of our filtering criteria in getting rid of the irrelevant local attribute features for the given image. Consider derivatives related to track-wise caption-based semantic realization. Our models achieve better performance than all those derivatives, suggesting that each semantic realization potentially contributes to the pseudo-word token learning. We present 3 serial CR results obtained using our models and the best performing baseline series across 3 datasets. The ground truth target images are highlighted in green boxes. In the first case, when it comes to simple modification of the global visual properties of an image's subjects, both our models and series correctly rank the target image in the first position. However, for more complex cases shown in B and C, which involve modifications to the local attributes or simultaneous adaptations to both the main subjects and local attributes, our method outperforms series in handling this situation more effectively. To sum up, in this work, we are first to explore the background textual inversion, that is mapping the image into a subject-oriented pseudo-word token and serial attribute-oriented pseudo-word tokens to realize zero-trust CR. We propose a dynamic local attribute feature extraction module to handle the problems of diverse attribute type of local attributes across images in different domains. We devised a track-wise caption-based semantic realization that enables the thorough interaction between pseudo-words and real words, and hence promote the aligning a pseudo-word token to the real-world token embedding space. That's all about my presentation. Thank you for listening.